Yeah, good evening. This is Ramavat Mohan. I have been post-graduated from IIT Kharagpur. So coming to the subject, today's subject is about the data structures. Basically, we will be dealing about the data structure stack. So the list of the topics, basically we'll be going through like what is meant by something about the introduction, like what is meant by the data structures, like how do we represent the data structures. Namely, stack here, we are taking the example of the stack as a data structure. There are different methodologies or data structures how we represent the stack. Namely, we have listed two here. We can represent the stack in the form of arrays. We can represent the stack in the form of linked list. So this is the we will not be discussing about the arrays, linked list here, the very basics. So what are the different operations that we are going to perform on the stacks? So basically, there are two operations. One is push operation and pop operations. So in the coming slides, we'll be discussing about these methodologies, like the operations, push operation, what is meant by push operation and what is meant by pop operation in detail. So first of all, a brief introduction about what is meant by the data structure. Data structure is nothing but it is how we organize the data and how we store the data in the computer so that it can be accessed very easily and in an efficient manner. So in another way, the data structure can be referred to as a logical or mathematical representation of data, which is as well as the implementation in a computer program. So the data structure is simply can be said that it is how we organize the data, how we are storing the data in a computer to represent useful information, and how the data is accessed in an efficient manner. So there are various data structures. So basically, something about the classification of the data structure. So we have got the linear data structure, and the other way is the non-linear data structure. So what is linear data structure? A linear data structure is nothing but we arrange the elements or the data items in a sequential manner, that is side by side, in a sequentially or linearly. So that is called as linear data structure. So there are various examples. So how the elements are or the items are arranged here is the elements are arranged next to each other, that is adjacent to each other data items. It can be like, say, for example, if you are considering an array uh, of integers or numbers, say. So, like, say, for example, you are like storing the data of the marks of a student in a particular subject. Let us say computer science, okay, or let us say data structure is one of the subjects where the marks of the total students of a particular class are arranged or stored in an array. So examples of other data structures of the linear data type are stacks and queues also, etc. And non-linear data structure. Here, the items, the data items or whatever data type is there, they are not arranged in an adjacent manner. That means the data structures where data elements are not placed adjacently. That is, they are not placed sequentially or linearly. Okay. So that is called as non-linear data structure. And there are certain examples like trees and graphs. So these data structures are a little complicated. So in the coming classes, we'll be discussing about that. So here is the diagram which depicts classification of data structure. So data structure is already we discussed about what is meant by linear data structure and what is meant by non-linear data structure, right? So again, the linear data structure has got further classified into two categories. One thing is static data structure, the other one is dynamic data structure. So what is linear data structure? We came to know that means the data items or the data is being arranged in an adjacent manner, side by side. So coming to the static data structure in the sense, in this type of data structure, what is happening is there is a fixed size. That means the size cannot be altered or changed. But in case of the dynamic data structure, like the examples of queue, stack, or linked list, here the memory size or the array, the data structure size can be dynamically. that means it is not fixed. Okay, but in case of array, that is a static data type, the size of the array will be fixed. We cannot change. Like say for example, there are a the total size of the array is 100. So there will be 100 memory locations or storage, or we can say storage rooms, okay, which can accommodate the marks of 100 students. So similarly, coming to the nonlinear data structure, where the data is not arranged in a sequential manner. So it is nonlinear. So the items are not adjacent to each other. So the best examples are the tree data structure and the graph data structure. Okay. So what are the applications of data structure? So why do we study data structures? So there are various applications like the data structures are utilized or useful in the databases. So how they are useful? They are useful in an to retrieve the data. Okay, the data structures, the data is being organized in a efficient manner, and we can retrieve and manipulate whatever data is in the database in an efficient and quick manner. Similarly, there are other applications we can make use of the data structures in the operating systems where we can manage the system resources such as memory, files, etc. And similarly, the other application is the computer graphics, where we can make use of the data structures to represent the geometric shapes and other graphical elements, okay, in the computer graphic applications. So finally, we have got applications even in the artificial intelligence. So nowadays, you people might be aware of that artificial intelligence is creating wonders, right? So data structures are used to represent knowledge and information in artificial intelligence systems. Like for example, you can talk about artificial intelligence, right? You can say when we visit the malls, right? So the doors will be automatically opening and closing of the doors. So it is like the sensors are there where artificial intelligence is making, and the implementation or the application of drones. In the best example is that in the agricultural sector, the drones are being used to detect or spray the fertilizers, or you can say that to trace the water resources and even the minerals, etc. So that's about the applications of data structures. So coming to the data structure, one of the examples is stack. So what do you mean by stack? And so generally speaking, stack is nothing but a neat pile of objects, so placed side by side or on top of one another. So it can be a rectangular or cylindrical pile of hay or straw. So here, this example, the example of a book as acting as a stack here. So there are the pile of books arranged on top of one another, right? So here, the pile of books here is nothing but the stack. So there is another example of the taking the example of a stack as food stack. Okay, so here you can think that there are some rotis or pulka placed one above the other. Okay, and again the other example is about the CD, that is okay. So computer hard disk, sorry, computer disk CD. So here they are placed one above the other. So when we talk about the definition of a stack, so what is actually meant by a stack? A stack is nothing but it is an ordered collection of some items into which new items may be inserted, and from which items may even be deleted or removed at one end. So here in case of the stack, whatever elements are entering or whatever elements are removing or removed or deleted, so they are from the same place. So we call that as top of the stack. So what is the top of the stack in the so a stack is nothing but it is an ordered collection of certain items into which we insert some data items, okay, and which from the same end we remove the certain elements. So here the in the next slide the picture clearly explains about, yeah. So let me show the diagram in the next slide. But meanwhile, there is certain information here. A stack is nothing but, already we know that it is a linear data structure, okay, which satisfies the following properties at any time. So here we have to know the characteristics or features of the stack. So the beauty of stack is that we allocate and deallocate. That means we insert the elements or we remove the elements, okay, from the top of the stack. That is from the same end or one end, we can say. So that phenomenon is called last in first out manner. So what is last in first out manner? I'll be explaining that in the next slide, where there is a figure which depicts it beautifully. So that is nothing but amongst all existing entries at any time, the last entry to have been allocated is the first that item. So whatever entry is lastly entered, that will be the one which will be firstly deleted or removed, or we can say deallocated. So here the beauty of stack is that the allocations and whatever deallocations, that is insertion and deletions, are performed at the same end. That is called the top of the stack. But the phenomena here is last in first out. So whoever enters lastly, that person will be removed firstly. So that is last in first out. So in a short form, it is called as LIFO. So only the last entry is accessible. So that means here we can access only the top of the stack. That is only one end of the stack will be accessed. So here is the diagram. So what I was explaining in the previous slide. So here is the stack. Here is the stack, which is like, say, we can imagine like the people entering the cinema theater or a particular room, or you can think of a stack of books, or you can think of a pile of plates or a pile of what rotis or food stack. You can. So here, what is happening is, let us say that let us say this is an individual or a person. So the person is entering. So we call that operation as push operation. That means the insertion or the allocation is called the push operation. That means this is the push operation where the certain data item is entered into the memory or the stack. Okay, so this person, the whoever is the person is there, so he's entering, so he will be somewhere here, right? So similarly, let us say here, like the stack consists of 1, 2, 3, 4, 5, 6, right? So there are 6 people, let us say, have entered the room or theater. So he's the last person who has entered the theater or the room, right? So, and this person who has entered the lastly will be the first person to go out. That means he will be deallocated or removed, okay, from that theater or room. So that operation is called pop operation. So here we can take the example beautifully. So stack nothing but last in, first out. What I said is, let us say that there are 3 individuals here. So he is the first individual entering the room, one, the second individual, and the third individual. So they are entering here. So this is the in is nothing but the push operation, whereas the out is nothing but the pop operation. That means the deallocation or the removal, okay, or moving out of the room. So this diagram talks about the push operation. Yeah, this figure like depicts like the people who were like the 3 people were there, no? They have entered the room here. So they are like placed like this. So one is here at the bottom of the stack. Next comes 2, he's in the middle, and 3 is at the top of the stack. So this person, the person who is represented by 3, he is at the top of the stack. So this 3 is the last in, right? But he will be the first out. That means third, the person represented by 3 is the person who has entered the room or theater lastly, but he is the one to go out. That is, he is the one to be removed firstly. So last, whoever has entered the stack or the room lastly will be the first person to be removed from the stack. So that is the push and pop operations of the stack. So here, like the operation, pop operation has taken place. So last in, first out has taken place. So here, the person who is represented by 3 is the first one to go out. Then 2 is thrown out, and lastly, the first who has entered will be the last one to go. Okay, so that is the functionality of the stack. So what are the applications of the stack? So there are beautiful applications about the stack. Like the stack can be represented in when we for example, when we visit the web browser, right? So we check certain at certain point of time, we just go back and check the history of the web browser, right? So to check the history of any particular web browser is one of the applications of the stacks. Similarly, when you are using the text editor, so when you undo or redo, so when you undo, the undo sequence will be like going back to the history, right? So like what was the previous step? So that is one of the applications that is about the text editor and saving local variables. So in the C programming language, we have a beautiful concept about the functions. So there, the concept of recursion takes place. So one function calls another repeatedly. So that is the stacks is beautifully explaining or implementing or is applied as to represent the functions in the C language or any language. So how do we represent a stack? So already I told you that stack can be represented in a computer in the following two ways. Like we can represent the stack in the form of an array data structure, and the other way is by the linked list representation. So here goes the array-based stack. Okay, how we are representing the stack in the form of an array, right? So a simple way of implementing the stack uses an array here. So here in the figure, you can see that this is the stack. Okay, the name of the stack is yes. So here there are some 10 locations. Let us say that. So A, B, C, D are the data types. That is the char data types are entered into the index 1, 2, 3, 4. Actually, in any programming language, we initiate the index with 0, but here for our easy understanding, I have taken as 1. So there are n rooms here. Okay, so n storage locations or n empty rooms, let us say. So 1, 2, 3, 4 are filled with some characters, A, B, C, D, that is the English alphabets. So here, the index of 4 is nothing but top, representing the top of the stack. Okay, and this is the index 1 is called as the bottom of the stack. So a variable top contains the location of the uh, top of the element at any point of the. So here the memory location 4, the memory location 4, which occupy which is storing the variable d or the alphabet d, is represented by top. So array-based stack. So a stack is an ordered collection of items. Already we know the definition, like into which new items may be inserted and the other items can be deleted. So the index which represents 4 is nothing but representing the top of the stack. So here 1 is at the bottom. Here in the figure you can see that there are n items. Like say the size of the array is n. So this is the n minus 1th index. So similarly, there are like ABCD 4 in memory locations are occupied with the stack. So here the array-based stack is represented in a step-by-step manner, very, very clearly. So let us understand this. So here, initially the stack is like the top of the stack is representing the location D here. Okay, so which is nothing but index 4. So what we are doing, we are inserting some element. That is, the push operation is being implemented here. Okay, so when we are inserting an element E, the top is incremented by 1. That is top equal to top plus 1. So it keeps on like when the push operation is performed. Okay, the top is increased or incremented by 1. The index is incremented by 1. So here, like the push operation is performed 3 times here, okay, 4 times. So you can easily understand here now the position of the top is at H. So the storage or the data items The total data is items in the stack is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 items or 8 alphabets stored in the stack. So similarly here the opposite, that is the pop operation is being implemented. Like the position of top is at the index 8. Okay. So now the item H, that is alphabet H, is being popped or removed or deleted or deallocated. Then the top is decremented by 1. So similarly, the element G is being removed. So the top is decremented by 1. Again, F is removed. So in the similar manner, we have come to the original stack where we had 4 elements in that. So here in the previous slide, we talked about the push operation. Here we are talking about the pop operation. So here it's a combination of both the push and pop operations. So whatever operations, what are the operations? There are 2 operations performed on the stack, right? That is push operation. So this one depicts the push operation up till this, and the downward, this is your pop operation. That means deallocation or removal is taking place. But here in this case, we have got the push operation where we are inserting the elements into the stack. That is nothing but array representation of the stack. So there are various sequences like how the push and pop operations are carried out systematically. So array-based stack. So whatever diagram we have discussed, the same thing here. So the push operation is explained here in this manner. Okay. So we have to fix the size of the stack. Nothing but we are representing array, right? So array is a static data type, right? So initially, in the beginning only, we have to allocate the size of the stack. So we can say that the maximum size of the stack, this variable is nothing but it represents the maximum size of the stack. Okay, maximum size of the stack, like where the data items could be represented. So it represents the maximum number of elements that can be held by the stack. So here the name of the stack is represented by S, and there are alphabets, and these are the indexes, right? So there is n. N is nothing but the maximum size of the array or stack in here. So where number, like a different number of items could be stored. So when we represent a stack in terms of array, there are like some conditions to be checked. So the condition here, if top equal to 0 or top equal to null. So top equal to 0, that means if the index of top is 0, or if top equal to null, null means empty. That means there is nothing in the stack. Here you can see this in the diagram. Here top is equal to null. That means top is equal to null or 0. Then what is happening here? The stack is empty. That means there is nothing in the stack. So here in this stack or array, we have taken the maximum size as 8. Okay. So it can give accommodation to only 8 data items. Okay. Or 8 people, we can say. And there is another condition to be checked. That is top equal to maximum size of the stack. It indicates that the stack is full. So these are 2 conditions where we have to check whether the stack is empty or stack is full. So here the stack is full. So here initially the stack top was here, right? Let us say in the previous example we have taken. So let us say that the top is at the index 4, and these elements E, F, G, H, after the 4 push operations, what is happening? The maximum size of the stack is attained or achieved at index 8, right? So now the top will be moved here. Okay, the top will be moved at the position of maximum size of the stack, that is 8, index 8. So the top comes here. So if top equal to maximum size of the stack, then it indicates that the stack is full. So if you want to further perform the push operation, you are not able to do it. Why? Why? Because the array size is only like limited to 8. The size of the array is 8. So when you accommodate the 9th element, it is very difficult. Why? Because the condition is failing. So top equal to maximum size of the stack, max STK, that indicates that the stack is full, so that you can't further perform the push operation. Okay. So whatever I was explaining, that is depicted here. So the maximum size of the stack is 8. So you can see here 1, 2, 3, 4, 6, 7, 8 maximum size of the stack, and top is here. So 4 more items can be added in the stack. Why? Because these 4 items are empty here, right? So the 5th index, 6th, 7th, 8th. There are 4 empty rooms where they can. So top is pointing to the index 4. The D is stored in that index 4, right? So 4 more push operations can be performed in this stack. So operations on stack, two basic operations as I already discussed. So push is the term used to insert an element into the stack, whereas pop is nothing but it is a term used to delete or remove a particular element from the stack.